Hi, I am Ms. To. Today we will look at Chapter 8.1A, Properties of Parallelogram. So, this is a parallelogram, 平行四邊形. In geometry, a polygon with four sides is called a quadrilateral. So all these shapes here, a square, a rectangle, a trapezium, a parallelogram, a rhombus, and a kite are all quadrilaterals. Before we look at the properties of a parallelogram, let's look at some common terms that we always used. First one, opposite sides. 對邊. So for example, in this diagram, AB and DC, they are opposite to each other, so they are a pair of opposite sides. And for example, BC and AD, they are opposite to each other. They are a pair of opposite sides. Second term, opposite angles. 對角. So here, for example, angle A and C, they are angles opposite to each other. So they are a pair of opposite angles. And same for angle B and angle D. They are opposite to each other, so they are another pair of opposite angles. Next is diagonals, 對角線. So a line segment joining two non-adjacent vertices is a diagonal. For example, AC and BD are diagonals. So for all quadrilaterals, they only have two diagonals. So let's look at the pentagon. How many diagonals does it have? Let's draw and count. 1, 2, 3, 4, 5. So a pentagon has 5 diagonals. As for a triangle, there are no non-adjacent angles, so it has no diagonals. Now let's focus on parallelogram. A quadrilateral with two pairs of parallel opposite sides is called a parallelogram, 平行四邊形. Now let's look at the properties of a parallelogram. The first one, for a parallelogram, the opposite sides are the same. For example, AB equals DC, and AD equals to BC. And for the reason, we use opposite sides of parallelogram. The second properties, the opposite angles of a parallelogram are equal. For example, in this figure, angle A and C are of the same size. Angle B and D are also of the same size. For the reason, we use opposite angles of parallelogram. And lastly, the diagonals of a parallelogram bisect each other. In the figure, the length of AE and EC are the same, and BE and ED are the same. For the reason, we use diagonals of parallelogram. Let's look at some examples. In the figure, ABCD is a parallelogram. So it's very important that you highlight the important points in the question. And E is a point on DC. AD equals AE. So these two sides are of the same length. AE equals 5 cm and EAD is 52 degrees. Find BC. So first of all, we can see that BC actually is the opposite side of AD. It's given that AD and AE are equal. So first of all, we can write down AD equals AE. And remember to write down the reason given. So we know that AD is 5 cm. So if we know the length of AD 5 cm, then we can find BC. BC equals AD. The reason: opposite sides of parallelogram. So BC is also 5 cm. Let's look at second part of the question. Part B, find angle ABC. This angle. By looking at the figure, we know that the opposite side is of the same size. So if we can find angle ADC, then we can find angle B. To find angle ADC, let's look at this triangle. This triangle is an isosceles triangle. So we can find angle ADE by the properties of an isosceles triangle. So for question B, first of all, we said that AD and AE are of the same length because it's given. Therefore, angle ADE is of the same size as angle AED. The reason: base angles, isosceles triangle. Using angle sum of triangle AED, we have angle ADE plus angle AED plus angle EAD equals 180 degrees. Angle sum of triangle. So G angle ADE plus 52 equals 180. So angle ADE is 64 degrees. So lastly, because angle ABC is opposite to angle ADE in the parallelogram, so it's also 64 degrees. The reason is opposite angles of parallelogram.